All right, everyone, we are going to be starting our unit now on solutions, acids, and bases. So the basic idea of what a solution is a solution is anytime something has dissolved in something else. Now, usually the thing it's dissolving in is going to be water for us, but obviously that's not always the case. There are things that can dissolve in other things. We learned when we talked about IMFs that like dissolves like, so polar things or ionic things, things with positive negative charges are going to dissolve in things that have positive negative charges, and things that don't won't. Okay? So let's go ahead and get started. So the solute is the substance that is being dissolved. So the solute is the one that is being dissolved. Maybe we're talking about salt or sugar or whatever, okay? And so the solute is usually going to be going from a solid to aqueous state because it's dissolving. It's dissolving in the solvent. That is the substance you are dissolving the solute into. And this is usually water, very often. It's not always, but it usually is. And then once they come together, we have the mixture of the solute and solvent. It is often aqueous, but it can be solid, aqueous, or gas. So we've talked about this term concentration before. So the term concentration is referring to how much of something you have in a certain area. Specifically, it's referring to the ratio of solute to solvent. And concentration is represented with a pair of brackets, and we'll come back to using that soon. So the ratio of solute to solvent determines the concentration of the solution. And when we're talking about the ability of something to dissolve, we've mentioned this in the past, the ability of something to dissolve is the solubility of that substance. And solubility can be affected by changes in temperature or pressure. Because by changing this variable, by changing temperature or changing pressure, you change the space between the molecules of solvent, allowing more or less solute to be dissolved between them. So if I had water that was cold, well, the particles are going to be very close together. So if I'm trying to dissolve this in there, I might be able to, but it's going to be a little bit more difficult. But if I have something that's warm, particles will be more spread out, so it's going to be easier to dissolve more. I can dissolve more because I would have more room between them to actually get the particles in. Now, when we're talking about solubility, we see that obviously there is a relationship between the ability of something to dissolve and the temperature of the substance or the pressure of the substance. So the way we see this representation is through solubility curves. So solubility curve graphs show the relationship between the amount of solute that can be dissolved at specific temperatures. So it tells us, we see that the wider the particles get apart, the more likely we're going to be to dissolve particles in there. So a solubility curve tells us, okay, well, for a specific substance, here is what you can expect. At that temperature, here's how much of the solute you should be able to get. So the amount of solute that can dissolve is measured in grams of solute per 100 grams of water. Grams of solute per 100 grams of water. I did put here also, we talk about grams, sometimes we see milliliters, but 1 gram of water is 1 milliliter of water. So water's, the kind of metric system was based off of that to an extent. So if I have exactly 1 gram of water, it should occupy 1 milliliter of water. So when we're reading a solubility curve, we're going to match the amount of solute you are attempting to dissolve at the temperature given to see if it's going to be able to dissolve. So right now, I'm going to be starting to use 3 different colored highlighters. Pause this video now. Go ahead and grab yourself those highlighters. I'm using orange, green, and pink. So when we're looking at a solubility curve, this is what we're looking at here. So across the bottom, we have temperature. Up the y-axis, we have solubility. The grams of solute that can dissolve per 100 grams of water. So solubility goes up. If I have right here, I'm saying 130 grams of whatever the substance is can dissolve in 100 grams of water. So when I'm looking at this, let's just look at this and let's base it on KNO3. So for KNO3, I'm going to highlight that line pink. Okay, so we're just working with KNO3. We can see there's a lot of different substances on this chart, but for right now, we are just focused on that line that I have just highlighted pink. So this line represents the max solute that can dissolve at that temperature. And this is meant to say that it is at equilibrium. So over here we see if a point lies on the line for that substance. Point lies on the line for that substance. Solution is considered to be saturated at that temperature. Sometimes we also call that a concentrated solution. And when a solution is saturated, this means that the solute and solvent are in what is called dynamic equilibrium. So on that line, we're saying that on that line, if I said, okay, it is 50 degrees, how much KNO3 can I dissolve in 100 grams of water? I would go up and I would say, oh, I can dissolve 80 grams. If I try to put more, it's not going to dissolve. If I put less, well, it's going to dissolve and there will still be some more room. So we're saying that this is really the maximum amount of space that I have to put that in. Okay? Or this is saying if I'm using the maximum amount of space in 100 grams of water, this is how much of that substance I can fit. So the next one is a point lying below the line for that substance. So for KNO3, that's going to be anywhere in here. Oops, crooked. Point lies below the line for that substance. It is considered to be unsaturated. We also call this dilute or diluted, which means that more of the solute could still be dissolved. So if I'm at 50 degrees and I've only put in 50 grams of KNO3, I'm below the line of solubility for KNO3, which means I could still dissolve more. That is anything under here at these temperatures with these grams, if it lands in this orange area, it will completely dissolve. On the other side, we have points lying above the line for that substance. So that would be anywhere in here. If I'm above the line for that substance, so let's go back and think. So if I'm on the line for that substance, so I'm on this pink line, that means that if I put that amount in at that temperature, it is going to perfectly dissolve. Perfectly dissolve. The maximum amount I can perfectly dissolve. If I'm above that, what that means is that I can't dissolve anymore. And so at the pink line is where I can dissolve the maximum amount. Anything above that is not going to dissolve. And so what we're going to see is that if a point lies above the line for the substance, it would be considered a supersaturated solution, which is temporary, and any extra will precipitate out. Any extra will precipitate out. So what we're really saying is, if I'm in the green zone, I have more solute than the solvent can handle. If I'm in the orange area, I can still fit more solute in the solvent. So, tomorrow what we're going to be doing is starting with practicing a little bit of reading solubility tables. So go back over this, rewatch this part, make sure you're understanding kind of what I'm saying here. When we're talking about solubility, it's the ability of something to dissolve. Particularly, we're talking about water here. So per 100 grams of water, how much can dissolve? That's what this particular table is focused on. So make sure that you're understanding a little bit about what it means to be above the line, on the line, or below the line. Now remember, I highlighted this just for KNO3. If I had highlighted this for NH4Cl, then everything above that line would be green, it would be pink, everything below would be orange. If I had done it for NH3, everything above the line would be green, it would be pink, anything below would be orange. So I did just KNO3 on this graph. When you get graphs that you're looking at for solubility curves, oftentimes they're not going to be highlighted because you want to be able to use it for multiple substances at a time. All right, so I'm going to stop there. Tomorrow we're going to start picking up practice, and I will see you then. Sorry, I stopped the recording too early. I was like, whoops. All right, see you tomorrow.